Hello, so today we'll be finding the electric field at the position of charge Q. This one right here. And we have our formula right here where electric charge is equal to our Coulomb constant times the charge, or electric field is equal to Coulomb constant times the charge divided by the distance between the two charges squared. So for these, to find Q, we will need to add up the x and y component of this one and add up the x and y the x component of this one. And as we can see, this one will have a y and an x component. And the way we would find this is, since this is 60 degrees, we'll just use this angle. So, in our triangle, we have 60 degrees, and this will be our, we'll call it E1x, E1y. And then this one will be E1x. And those two both will equal, well, when we start plugging it into this formula, we will get E1 equals our Coulomb constant times the charge, which we know our charge for between this one and this one, or our charge here, because this is our source charge. Our charge here is 7 microcoulombs, so that's 7 times 10 to the power of -6. And then we divide it by the distance between them, which is L, and our L is 0.65 squared. And when we break that up, well, this will be for the x and the y, so we will have our x, and we did say our x is this, and it will be the cosine of 60. And then this one will equal the sine of 60, because for this one we will have opposite and hypotenuse for the y, and then the x we have adjacent and hypotenuse. So for the x it will be cosine 60, and it'll be a negative cosine. And then we will add our sine 60. And the x is negative because these two are both positive. So, since they're both positive, they will repel each other. Well, in that case, then the y is also negative. And when we do our calculations, this will be our I hat, and then this will be our j hat. And then when we get our overall number here, then multiply it out to both sides. Multiply it out. We should get -74473.37 I hat and then subtracting 128,991.66 j hat. And then that's just for how this charge right here interacts with this. And to find this one, all we do is basically the same thing. Since this only has an x direction, we don't really need to like calculate a y or anything. So we have our E2 equals our Coulomb constant times the absolute value of that charge, which is -4 microcoulombs, 10 to the -6, and then all divided by the distance, which we know again is 0.65 squared. And once we get that, this will be another I hat in itself. And once we get that, we should get our E2 to equal 85,112.43 I hat. And once we have both of these, we now have all of the components that are acting on our Q right here. And from here, we will do the vector addition, so our electric field total will equal E1 plus E2. And when we write that out, we get, so this is our E1, and then we want to add our E2, which is the 85,112. And when we add that all together, we do get that our total electric field at that charge, we get it to be we will do our scientific notation for this one real quick. So we'll just make them times 10 to the power of 3. So we'll put the period there, we'll put it there, and then we'll put it there. And once we get that, we should get 10.64 times 10 to the 3 I hat minus 128.99 times 10 to the 3 j hat. And this should be our answer for that problem.